So here I have labeled the positions of the persons as well as the helicopter as like this. So this A is the position of person 1 and B is the position of the person 2 and C represents the position of the helicopter. And we have to determine at what height the helicopter is flying when the distance between the two persons is 100 feet. So to determine the height at which the helicopter is flying, we drop a perpendicular from the position C, that is from vertices C of this triangle to the base AB. So this is the perpendicular and we represent this height as h. Now we have to find the value of h. So first let's consider the one of the right triangle OAC. So we consider this right triangle OAC. In this triangle, we apply the trigonometric ratio, that is a tangent of 25 degree, and this is equal to opposite side by adjacent side. The opposite side to angle 25 is OC and the adjacent side to angle 25 degree is OA. And I have marked the OA distance as x. So if OA is x, then OB equals 100 minus x, because AB is 100. The total distance between the two persons is 100 feet. So we assumed OA equal to x, then OB equal to 100 minus x. So using this relation, we substitute the values for OC and OA. OC is represented by the height h and OA is represented by the variable x. So from this we solve for h. So h is equal to, if we multiply both sides by x, we get x times of tan 25. Let this be equation 1. In the same way, now we consider another right triangle OCB. So here once again I'm going to write down the tangent relation, that is in right triangle OBC, we write relation for tangent 45. So tangent 45 is opposite side, which is OC, divided by adjacent side, which is OB. So you can write down this as tangent 45. I'm sorry, it is tangent 40 equals OC divided by OB. Now let me write down OC as h. So therefore this becomes tangent 40 equal to h over OB is 100 minus x. I can solve for h from this equation when I multiply both sides by 100 minus x. So I'll be getting 100 minus x times of tangent 40, that is tan 40 equal to h. Let this be equation 2. Using the two equations 1 and 2, we can see that both represents the same quantity, that is h. So this is h expressed as x times of tan 25, and this is also h expressed as 100 minus x times of tangent 45. So which means this x tan 25 will be equal to 100 minus x times tangent 40. So let me set up that equation. So I can write down this as x tan 25 equals 100 minus x times of tan 40. Now let's solve for x from this equation. So we write the left side as it is, x times tan 25 equal to, we distribute this 100 with tan 45, that is 100 minus x with tan 45. So when we do that, we get 100 times of tan 40 minus x times of tan 40 on the right side. Now let me add this quantity x tan 40 on both sides. So when I do that, I'll be getting x tan 25 plus x tan 40 equals 100 times tan 40. I can factor x from the left hand side. So when I do that, I get x times of tan 25 plus tan 40. These are all in degrees, equals 100 times tan 40. Now let me divide both sides by this quantity, that is tan 25 plus tan 40. So when I do that, I get x on the left side. This is equal to 100 times tan 40 over tan 25 plus tan 40. So we can plug this into the calculator. Remember that the angle or the degrees has to be in degree mode, and when we do that, we get x equal to 64.28 feet. To determine the height, we can substitute the value of x into the equation 1, that is into this equation. We know that h equals x times of tan 25. So let me copy that. So we have h equals x times of tan 25, which means I can replace the value of x as 64.28 times of tan 25. So we can plug this into the calculator, and when we do that, we get 29.97 feet, and this is approximately equal to 30 feet. So therefore we say that the helicopter is flying at a height of 30 feet from both the observers.